Alright, solving indefinite integrals with just power and trig functions. Because since we're going to be doing other kinds of functions later, like exponentials and logarithms and that sort of thing. These are the same thing as antiderivatives in essence. It's basically just undoing the derivative. So if we take the derivative of x squared, we get 2x. So how can we think about the way we go backwards from here to here? And the way we do it with power functions is, well, from here, we'd raise the power by 1, so we'd write 2x squared, and we divide by the new power, so divide by 2, and that's x squared. However, when we're going that backwards direction, a lot of things have a derivative of 2x. X squared has a derivative of 2x, but so does x squared plus 5, and so does x squared plus 100, because we take these derivatives and we get 2x. So does x squared minus 1,000. So we have there's a constant there, and we don't know what it is. So we have to leave the fact that, hey, there could be any constant added on there, and all of those things have a slope of 2x. And so it's desperately important that you remember to do this plus c anytime you have an indefinite integral. Now let's talk real quick about what indefinite integral means. There's the whole integral sign thing, which is this dude. If there are numbers here, that's a definite integral because it has endpoints, so it's defined. If we don't have numbers there, that's an indefinite integral because the interval is not defined. Definite integrals yield numbers, like the answer is a number, like 5. Indefinite integrals yield equations, so the answer would be like x squared minus 7 or something like that. So let's hop straight into these problems here. First equation I'm solving is the integral of x squared root 3x plus 6x. All right, in this section, I'm going to give you things that you need to simplify before you take the integral of. There's no product rule in integrals. There's no quotient rule in integrals. We always have to rewrite integrals to be in a form where we can deal with them. So I'm going to rewrite this one. This is x to the 1/3. So really, this term is x to the 2 plus 1/3 would be 7/3. So to show a little more work there, I have x to the 2 times x to the 1/3. So I add these. X to the 2 is x to the 6/3 plus, or times rather, x to the 1/3. I add their exponents, I get x to the 7/3. That's something I can deal with. That's easy to raise the power by 1 and divide by the power. All right, second one was, we didn't have to rewrite that. 6x is already nice. All right, let's take the integral. We get x to the, adding 1 to this would be 10/3 divided by 10/3. Because we always raise the power by 1 and divide by the new power. Here we get 6x squared divided by 2, because that's our new power there. And then plus c. And this would be an acceptable way to leave your answer. Alternatively, I could simplify this a little bit. 3/10 x to the 10/3 plus 3x squared plus c. And that would be a better way of writing it. All right, one down. Next. Okay, no chain rule. We have to expand this. We have no other choice. There's not a way to deal with this reasonably. Like if you try to use the chain rule and get z squared minus 5 to the 4th and then divide by 2z, you can't do that. That would create a, it's bad. So we have to expand this. We have to. We can only use like power rule type stuff when we do integrals. So I'm going to expand it right now. I'm going to use Pascal's triangle because it's just easier with cubes. So that's this squared level of Pascal's triangle. This is the cube level. So I'm going to have 1 times the first coefficient cubed. So 1 times z squared cubed, which is z to the 6th, plus 3 times the first thing squared times the second thing. So 3z to the fourth times a negative 5 plus 3 times the first thing times the second thing squared, which is 25. And my Pascal's triangle's totally in the way. So I will transpose it over here. But I'm on the last step, which is just the coefficient's going to be 1, and it's going to be my last thing cubed, which is negative 5 cubed. Cool. So I'm going to write my integral as the integral of z to the sixth minus 15z to the fourth plus 75z squared minus 125 dz. I added this dz here because this is the way we write integrals. You need one of these dudes, and you need the variable you are integrating. So this means you're doing the integral, and this means this is what you're doing the integral with respect to. So just like in derivatives, we had d over dx, and this meant take the derivative, and this meant with respect to x. With integrals, we have a symbol here and a d whatever here. That tells you which variable you're integrating. It's kind of obvious here we're integrating z. All right, so we take the integral, we get z to the seventh over 7 minus 15z to the fifth over 5 plus 75z cubed over 3 minus 125z plus c. And this is an acceptable way to leave your answer, but there's a better answer, obviously, here. Z to the seventh over 7 stays, but this is minus 3z to the fifth plus 25z cubed and minus 125z plus c, and that is probably the best way to leave your answer. And that's it for this section.